Welcome to Heavy Networking, the flagship podcast of the Packet Pushers Podcast Network, coming to you weekly since 2010. Your hosts today are Ethan Banks, that's me, and Drew Conray Murray. You can follow us on LinkedIn and the Packet Pushers Community Slack group, and please do. Our topic today is digital twins and what you can do with them. And I am going to avoid going into rage mode about how marketing departments industry-wide have co-opted the term digital twin to conveniently describe whatever it is they are selling. Why? Because today's sponsor is, in my opinion, the original digital twin and one of the few vendors that can call themselves a digital twin without we consumers having to squint really hard to see how they got there. Forward Networks is joining us to chat about what a digital twin is and the positive impact such a thing can have on your network operations. Forward Networks is one of those tools I wish I'd had when I was a young packet mechanic, troubleshooting complex issues where everybody was pointing fingers at everybody else. It all would have been much easier with a true digital twin to help cut through office politics, opinions, and the blame thrower. Our guest today is Mike Lossmann. Mike is the technical product marketing manager at Forward Networks, and he's a fellow nerd who worked on all kinds of production networks before his current gig at Forward. Mike's going to catch us up on digital twins and what's been added to the Forward Networks platform since they last spent time with the Packet Pushers back in 2020. Mike, welcome to Heavy Networking. It's very nice to have you here, sir. And Mike, I want to jump right in with, I think, a necessary definition, digital twin. Would you define a digital twin for network engineers?
Sure. Let's think about what Google Maps did for navigation before we get into that. It eliminated the need for people to have to use paper maps, right? To always have that up-to-date view of whatever your directions were going to look like. If you wanted to stop at a specific point of interest, if you wanted to do something, if there was traffic along the road, right? Having Google Maps revolutionized how people drive today. Now let's look at networks, and now let's look at your traditional network engineer. How do they navigate their complex network environments? Old school maps, Visio diagrams. They can't ask the Visio diagram a question. They can't go, hey, Visio diagram, show me where this problem is, or show me the path between here and here. And oh, by the way, if this firewall is blocking it, let me know.
Oh, and what's worse about the Visio map is the one you do have, you can't ask it a question, but you look at it, it's a picture of history. It's what it was when you created the diagram, not what it is today.
You look in the corner in creation date, because that's how we actually used to do it. And it was created on October 12th, 1992. Okay, that's good. We don't use token ring anymore. We don't use any of this anymore. All that's gone, right? So a digital twin gives that organization, gives the whole organization, not just the network engineer, a complete 100% mathematically accurate view of the network, both on-premise and in the cloud, without ever sending a packet through it.
What do you mean by mathematically accurate?
So what I mean by mathematically accurate is we have a bunch of really smart co-founders. They're all PhD, so they're all Stanford PhDs. And this was one of their theses, where it was taking a concept called header space analysis, which essentially is just algebra, and taking in network configuration and state, running it through this algebraic model, and then spitting out this 100% mathematically accurate depiction of your network without sending a packet through it. It's the wildest math I've ever seen before in my life.
So that's why they're using the math, because the math is sort of a substitute for having to send packets through the network to see how things are actually connected.
Correct.
Got it. Okay.
Is it like graph theory math then?
So without getting into the weeds of like header space analysis, it's just a bunch of transfer functions that they're using in order to have a whole bunch of state go into one, and then it just starts choking it down as it goes down till you get that either flow that's allowed or the flow that's denied.
Okay, this is more important than I thought it was as far as the mathematically accurate component of what Forward is doing, in that you kind of assume with digital twins, it's more like a simulation of your network configurations, which it is. But rather than simulating a packet moving through and go, oh well, let's do some if then else or some case statements and deciding if it's going to actually make it through this ACL. We're figuring that out with math.
Yeah, we're figuring out with algebra. Yep.
Okay. Okay, so I'm starting to get a sense of what the digital twin is that Forward Networks is creating. Maybe another way to help us figure it out would be comparing it to some other things. How would a digital twin be different from your network represented by infrastructure as code?
So a digital twin to infrastructure as code is just kind of what you're looking at. It's just a method for managing the network configuration, right? And then you run it through a CI/CD pipeline to ensure that the checks you have inside of, let's say, Jenkins is going to pass it. And then however it gets implemented, it gets like implemented. Things you can't do to that is, oh, hey, show me where this IP address lives inside of your network, or show me the path between X and Y if you're troubleshooting something. And if there's a firewall in that path, what happens? Is that firewall blocking it? Is that firewall permitting it? If that firewall is blocking it, what can you do then at that point to, circumvent that firewall? There's features that we have where we can actually go in and turn all firewalls into what we call permit all mode. So any security device that's in a path. So if like you're looking at a path between A and B, and it's going through a bunch of firewalls, and you have one firewall that's denying it, a network guy is going to look at that and go, hey, what is going on behind that firewall? How do I know that there's end-to-end connectivity? Because if I go to the change board and I say, hey, please change gods, let me make this change, they're going to go, no, we need to know for sure this change is going to work, because we're not going to give you another change because you asked for too many changes, and 9 times out of 10, they don't work. So with this permit all mode that you can't get in a IAC environment, it actually allows you to take a security device, remove it from the model. So we're read-only. So let's just, before we get any further, we're a read-only platform. We never write back into the infrastructure. So this is all done in the twin. Any cloud security construct or any firewall gets ignored. You see the full path. And then in our path view, you can see which firewalls were actually blocked or were blocking the traffic. So now you have a represented view of, okay, these 4 firewalls and this Amazon security group needs to get changed for this flow to work.
So the digital twin piece of this also has some malleability. I can mix things up a little bit, change things, and then create these what if scenarios that are going to help me understand, if I make this change in my production network, this is how things are going to behave.
So right now, today, it's just with ACLs.
Yeah.
So you can go in and you can modify an ACL and see what that would do, but
on the existing, okay.
Yeah.
So I've got a twin of my environment all plumbed together the way it's plumbed, all my interfaces stitched in, and then I can add I could modify an ACL or firewall rules or policy and see how that would impact flows. Okay.
Yes. So now, but this permit all doesn't have you have to modify anything. It's just a push of a button, and it'll actually go through and negate all the security rules that are in this particular path.
Would you classify a digital twin as a kind of source of truth or different from a source of truth? Because I know there's a lot of debate about what a source of truth actually is.
I would say that our digital twin is a source of truth in several different scenarios, right? So we're a source of truth when it comes to the devices that you have inside the infrastructure. And it's a source of truth of every path that a packet can take, going from whatever point to whatever point, whether it's on-premise or in the cloud.
Would I want to then sort of have this source of truth in my pipeline when I'm considering changes and so on? Or, how does it fit into what I would usually do with like a Netbox or something?
So yes, you would want this in your pipeline. So we actually have a integration with iTential. And what would happen is we would be the assurance platform inside that. When you actually define your change inside of iTential, we can set up what's called verification checks. Whenever a network engineer goes in to make a change, what do they generally do when they go in to make that change? They are going in and they're doing a bunch of show commands, putting it into a notepad. Then they make the change. Then they do a bunch of show commands again, and they put those into another notepad. And then they kind of do a stare and compare if we're talking about a non-automated way of making a change.
Mm-hmm.
With the automation piece of it, it's the automation tool may have some checks and balances in it, but it doesn't have the full picture of the network per se. But with Forward, if you inject it inside of a iTential workflow, what could actually happen is iTential could instruct Forward to take a snapshot. iTential will make the change. then Itensha will instruct forward to take another snapshot, and then you can do a stare and compare of the verification checks. Whereas if the pre-check you had verifications that were passing, now in the post-check you had verifications that were failing, Itensha could then hook into whatever they can hook into to alert the end user, hey, you know what? This change is failing because these verification checks are failing.
Okay. Got it.
So, Mike, it's day one. I've bought Forward Networks and I need to get my digital twin built. Explain that process.
So what we need is we go out to the network and we collect data. So all we need are read-only credentials, either on your premise or in AWS, Azure, or GCP. We need nothing to be able to write back into it. You can either start with a seed device and we can learn your network from a seed device. You can do the old spray and pray subnet scans, or you can upload your inventory from, let's say, ServiceNow or Netbox as a CSV file. We'll process that. We'll actually build the digital twin. And then there's checks that we can run that will say, hey, you know what? You uploaded these, or, you had us ingest these 500 devices. We see that there's 4 that you missed. Are these 4, do you know these 4 exist? Did you just miss them? And then you have the ability to add them. So that old 2621XM router that's connected to the internet that nobody but John knows about, and John's somewhere doing something that John does because he's the network guru. Now we know it's still there, and that thing probably hasn't been updated since, I don't know, 2011. And it's connected to the internet. Yeah. And it's connected to the internet, and it has every vulnerability under the sun. So now you know that even if you think your sources of truth are correct when it comes to your network inventory, now you know your sources of truth are correct because we can find stuff that you may not know about.
And how are you doing that finding? I assume you're not actually doing like a full network discovery. Are you intuiting it from, sort of the state information of the devices that you've ingested?
Yep.
Okay.
Yep. And to have a shameless plug for one of our customers, at Network Field Day this past February, one of our customers actually got up and spoke about how they had issues with inventory and how Forward got them to 100% inventory that they now feed into tools like Netbox and ServiceNow.
Okay.
Now, during that, so there's a discovery process, and there's lots of ways that can happen, right? You described, I could seed it with a list. I could send you to a seed device, and you can figure it out from there. I'm going to assume you need credentials because you're actually going to log into the device. Okay, here's the question. You log into the device. What information are you pulling that becomes part of the model?
So what we're pulling config and state information. Now, this is where when I talk to people about it and the security guys are in the background and they go, wait a minute, you have this thing you call a collector that's essentially a black box to me that's hitting devices. How do I know what you're running? I need to make sure I know what you're running so we can ensure that you're not running commands that we don't want you to run. We publish everything that we run to build the model. So if you're looking to model a Cisco XR9000, we'll give you the list of commands that we run to build the model for that specific device. Now, the cool thing is let's just say you want a command that we don't run to build the model, but you want to get data out of the network. For instance, you want to go on your switches and you want to pull TCAM information because you want to use our network query engine to alert on TCAM changes. We have the ability to do custom commands where you could actually import custom commands into the platform and use them in our query engine to write queries based upon them, as well as the standard commands that we would take into.
So when you say config information and state information, that tells me a couple of things. One, config. This is the configuration that's on the box. It is how the engineer, the architect intended for this device to function. State information would be things like routing tables, forwarding tables, and the such like. You can parse all that information and therefore understand how the device is actually processing packets as packets go through the device.
Yep, that is 100% accurate.
Okay, so that means you have a deep understanding of an awful lot going on there. You know routing protocols. You know things happening at layer 2. You know things happening at layer 3.
Yep.
There could be complexity with overlays, tunnels.
SD-WAN,
it could be
VXLAN, all that stuff. We pull it all in. We can model it, and if you're looking at an overlay, we can actually show you the overlay to underlay correlation. So if you are troubleshooting a VXLAN environment, you can look at the higher level VXLAN path, and then you can look at the underlay, and you can see the n number of paths that underlay can take. And then you can start looking at those underlay paths to see if there's an issue in the underlay.
Do you know about physical device errors? Things like this optics going sideways on me. It logs an error once in a while. Anything, stuff that detailed?
If we're able to run that as a custom command that we can pull in, we can run we could run queries against that where we can have thresholds set inside of the query. And then as we do the collection, it'll alert if the optic gets to a certain level. The other piece of that too, right, is we also do SNMP collecting for MIB2. So CPU, interface utilization, all that good stuff that we paint on top of the model. So that happens at that happens at a specific collection interval that you want the SNMP to happen, depending on the size of your network. You may want it at 5 minutes, you may want it at 10 minutes. Then as you do path searching, we can show you, oh, hey, between this core device and this core device, this link is oversaturated, or this CPU on this core device is over the threshold that you had set for it.
But Forward Networks is not a monitoring platform. Is that fair to say?
It's not, but when you're troubleshooting a path that you don't know what the problem could be, having that extra data to overlay on top of it can help the engineer understand, oh, hey, the problem is this router is running hot, or this link is running hot.
But just trying to disambiguate for people that are listening to this and going, wait, could this thing replace my NMS? It's not what it's intended to do. No. It's augmentation of your NMS.
Correct.
It may have some parallel functions there. It might be able to see some of the same data, but really this is a different tool.
Completely different tool.
Okay.
So what kind of network devices does Forward know about? I presume routers and switches. Are there other things that you can learn about?
Routers, switches, load balancers, firewalls. So think of anything that's a packet pusher from layer 2 through 4. We also suck in layer 7 information from devices that support layer 7. So for instance, if you're testing, say, a zero trust policy, and you want to look at a path search and make sure that John can only access what John can access, you can run a path search that says, from anywhere to anywhere, and then have the user John. It'll show a bunch of paths, but it'll actually show you all the active paths that John had during that snapshot. And then you can see and make sure if that policy is working that way. There's other ways too that we can also look at zero trust too, to make sure that the policies are correct.
Okay, so routers, switches, firewalls, load balancers. How about things like wireless access points?
So wireless access points, we actually just added that. So we collect from we actually collect that from the wireless controller, and we can paint them onto the actual topology itself.
So one thing I'm gleaning from this is that I had sort of put digital twins in sort of the data center category. It was used for data center environments, but it sounds like you can also do campus.
You can do campus, you can do cloud.
Okay.
Wait, you can do cloud. What does that mean?
So let's look at this euphoric state where you're a network guy who's been called to troubleshoot networking in the cloud, and you're a network guy who doesn't really understand what's happening in the cloud because you're a network guy, right? That was me previously. Even though I worked with the cloud a lot, I was very hesitant to learn the cloud, but now me and the cloud are best friends. So you can actually go in And if you're looking, say you have a workload that lives in AWS and another workload that lives in Azure, and you wanted to see a path between the two of them, that is next to impossible to build today in one UI, especially if you're crossing different regions in all these different cloud providers. What we do when we actually take all the cloud information in is you can look from a resource in AWS to a resource in Azure, and we could paint the picture straight across the same way we would do a path search inside of a data center or inside of your campus or inside of your WAN.
So you would know about Amazon VPCs. You would know if there's multiple VPCs, how traffic is flowing through those VPCs, whether you got hub and spoke or whatever your topology is. You understand the access lists that are in there, the different policies that are governing traffic through there. If we've got to jump again, as you're saying, from AWS over to Azure into, what are they? It's not a VPC. They call it a VWAN or something, whatever. Whatever it is they call it in Azure. You got the same knowledge of an Azure or a GCP environment.
Yep. So the really off the wall way that I actually explain the power to this to people when I'm in conferences, if anyone ever does this, please email me and let me know. But you can trace a path from GCP that transits Azure that ends up in AWS, and you can see the path end to end.
So now a third party question relating to cloud networking. There's lots of different products that stitch together my multi-cloud network environment. Do you deal with any of those?
We don't.
Okay. So you're dealing with native constructs that the providers. Yeah. Okay.
Correct.
So you mentioned being able to say, I want to see John's path or available paths through the network. Does this mean you are also modeling hosts that are attached to the network, or how far does this go?
So this goes down to the edge. So this goes down to the switch edge. So when we learn about a host, what we're learning about from that host is, a host with MAC ABC 123 is living off of this host. Right. We don't know what that host has. We just see it as an endpoint on a specific switch.
So essentially just a MAC address. You're not looking at the OS. You're not looking at anything else.
Yeah. We're not looking at any of that. What we do, what we kind of augment with that, but still we're not looking into the host, is we have integrations with Tenable SC and Rapid7. So we can pull hosts into the model that they discover, and we can actually set exposure points up for these specific hosts. So if you have a bunch of hosts that are in your contractor VPN and you want to see what their exposure is, right? You can do that in this platform by actually integrating with this and then setting that specific exposure point.
Okay, because you're able to also draw in information from some kind of endpoint device software.
Yeah.
Okay.
When the forward model is up and running, I've got my digital twin, it's live now. How does it stay current with the network state?
So it stays current with the network state via snapshots. So we are a snapshot-based platform. Those snapshots, we have our customers running them at any interval that feels comfortable to them, right? So we have some running it a few times a day. We have a few federal customers who run it at shift change. We have a few who run it multiple times a day. It depends on the layer of visibility that particular customer wants in that time frame. But if they're actively troubleshooting something, right? So if they're actively troubleshooting a path, we have this concept called real-time workspace refresh, where we will real-time update the path that you're currently troubleshooting. So you don't have to snapshot the entire network. You can snapshot just that small section that you're troubleshooting that path is in real time.
Yeah. Well, I was going to ask you about that, because if I'm snapshotting multiple times a day, I mean, if my network's huge, that's got to be burdensome to the platform, right?
Depending on how complex the network is, we have customers who collect tens of thousands of devices in 45 minutes, and we have customers who collect tens and thousands of devices in about 2 hours.
That's still way faster than I was expecting you to say. So, okay. So there's a lot of, okay. Just to be able to pull that off means you're doing parallel processing. You're querying a bunch of devices at the same time, pulling all the data back, and then being able to correlate it into a finalized model
Yep.
awful quick.
Yes.
So this sounds like
Yeah,
it's
no,
going
there's
to
nothing
be
more to say. There wasn't a question there.
Yeah. No, but it sounds like this is going to be running on some beefy hardware then.
So yes, so there are multiple places where we have, depending on the amount of devices that, let's talk about deployment models before I get into that piece.
Yeah.
We have our first and foremost way of deploying is in our SaaS instance. Our customers love our SaaS instance because it's no longer that they have to schlep, racks and racks of servers into a data center to be able to build a model like this, right?
Okay.
So SaaS first. Then we have our federal friends who will either want to have it in their bunkers somewhere or in their own cloud environments. And then we have some of our some of our financial friends who do the same thing. They'll either put it in their cloud or they'll put it on their premise. So our deployment model is forward SaaS, or we can give you the install files to either set it up in your Azure or AWS environment, or you can have it on-prem. And we have, depending on how big your environment is, we have guidelines of how big the clusters need to be in order to build this.
Makes sense.
So Forward's got all this information about my network. Now I'm a network engineer and I want to get information back out of this thing. How do I do that? Is there a CLI, GUI, API? How does it work?
So there is a GUI and there is a API, and our customers are split. So you'll have some who will go straight to Forward to do everything, and you have some of the more automation focused ones will actually hit all of our APIs, and then they'll bring us into another platform and use us as a piece of a bigger automation tool set that they have.
Well, like you mentioned, an intentional integration. That would be an example of an API integration.
That would be one. We have some who made their own dashboards from information that they can pull out of the platform. So it's not just going to us. It's, you can if you want to, but we have some who don't log into the UI and who just do that and get the data they want that way.
Okay, but I'm going to assume the vast majority of engineers, maybe not the vast majority, but a lot of folks are going to be using the GUI.
Yeah.
Talk to me about help me visualize what I'd be looking at, what I'm going to be pumping into the system. How do I ask it questions and get data back?
Yeah, am I clicking things? Do I have to learn a query language? How do I get data out of this?
So yes, and yes. So
okay.
Let's go on a journey. So when you first log into Forward app, what you're presented with our search screen. So there's a search bar on top that's very reminiscent of Google. Below that is a high-level view of your entire estate, broken out by location. So if you wanted to, you can click into specific locations and see what you want, but that's not going to show you what you want. It's just like, oh, you know what? I have a bunch of devices in London, or I have a bunch of devices in Atlanta. So let's say you want to know where a specific VLAN is configured. You go into the search bar, you type VLAN 111, hit enter. It'll show you every device, every switch port, every place where VLAN 111 is configured. The next thing in this search bar is, I'm going to keep saying Google for your network, right? So let's say you want to search for a specific prefix list name or a specific access list name. Go to the search bar, type in just the text, in outside, and hit enter. And it'll pull up every place where in outside is configured. The next thing you can do with it is, now this is where you start wanting to, my other favorite thing of being an ex-network guy, hunting down hosts in an environment. That was legitimately 80% of what I did at one of these companies. Hey, Mike, we need you to find this host in our hosting environment, or we need you to find this host in the enterprise environment because we don't know where it is anymore because we can't find it. Type the IP address or host name into the search bar. We will not only show you what switch port it's on, we'll show you if it goes through any security zones. We'll show you if Rapid7 or Tenable is there. We'll show you the host vulnerabilities that we learned from that platform. If you look over to the right side of the screen, what you'll also see is other textual information like, okay, this host belongs to these routes. But the thing that gets me every time I see it is we'll show you every access list this host is a part of, whether it's a host-based access list or it's a or its host lives in a subnet that's part of that access list. So now if you're decommissioning that host, you could now go in and clean up your firewall rules rather than just go, okay, we're going to decommission this SQL server. We're going to put this new server in its place. We're going to hope it has the same connectivity profile, which it's not because we're replacing it with a .NET server. And now you have ports open to it. You have more ports open to it that you need open to it. So it's a way to quickly look and say, oh, okay, if I'm decommissioning this guy, I have all these firewall rules that I now can get rid of. Now,
I got a little PTSD at the moment from having to do that by hand. I worked for some companies where there's a lot of M&A activity. And so there'd be a process over a couple of years of bringing the company in and consolidating their IT, working with their networks, making everything homogenous, where you'd be bringing in these new subnets and then decommissioning them as things progressed. Oh man, now you got to update the firewall policy and the VPN policy and all these other policies to try to figure all this stuff. Where is it all? Well, after a while, you kind of had a rhythm for it, but you were never 100% confident that you got them all. That would have been a great tool.
Or in a hosting environment with 100,000 servers just meandering in that hosting environment, right? It's yes.
Servers just wandering wherever.
Hey, I mean, that's what they do. These server guys will vMotion them, and that's just them wandering from place to place. And then like the best is like the infrastructure guy going, yeah, I've emotioned it to the server. Okay. I don't know what port it's on anymore. I don't know what port that server's connected to. And it's like, okay, all right, I'll find it. Give me a couple hours. So now to get the path. So there's ways you can search for paths. So we have a quick path search way where you don't need to know our tags to search. So there's a panel on the left-hand side of the screen where you can put in source IP, dest IP, protocol, and anything else you want to be able to try to figure out where, or to try to figure out what you want to see to paint this picture. If you did want to use the search bar, it's like how if you and I were just having a conversation like, hey, Mike, I want you to show me where this host is. So from this host to this host on this port. So you can have the easy button on the left side where that's all spelled out for you, or you can actually go from host A to host B, app ID, XYZ, L4 desk port, XYZ.
Now, when we were prepping for this call, Mike, you were telling us about the network query engine. Is that what you're describing here?
No, that's actually the search bar to just be able to do
that's a path search. That's just the search bar. Okay.
Yeah.
So what's the network query engine?
So network query engine is all of our customers love this thing. So it's a way to query your network. So when we take all this data in from all these different vendors, from all these different clouds, the one thing that we do is we normalize it. So it's not like you have to go, okay, I'm looking at a Cisco ASA. I need to know how a Cisco ASA will show an access list. Or I'm looking at a Palo Alto firewall. I need to know Palo Alto config to be able to get the information I want out of it. It's as simple as it's a language that looks very familiar to SQL, but it's not really SQL. So essentially, we take this data, we put it into our data model, normalize data into our data model, and then you just go in and say, okay, I want to see, all interfaces that are administratively up but operationally down. And then you can run a query based upon that. And then you can save that query as an intent check. A lot of what our customers use NQE for is actually auditing and compliance. So our federal friends, we have Cisco and Juniper STIGs, high and medium severity already built into the platform. So if they're going through and if they're getting audited on a specific STIG or something's happening where they need to make sure that they're STIG compliant, all that is in the platform. Then we have other customers who want to look at golden configuration changes. One thing that I struggled with when I was in the enterprise, and it's the first query I wrote when I came to Forward a year and a half ago, just to see how easy it would be, was we had an issue where engineers would go in and modify management access lists on firewalls. because they didn't want to go to jump servers. They didn't want to go to specific subnets to access the firewall. They wanted to access the firewall wherever they wanted to access the firewall from. So it kind of violated our golden config policy for this specific set of devices. So now the query is written, and then once that query is written, we can add it to verify our verification platform. So when a collection is done, all of the intents that we were talking about, all of the NQE verifications that are added are all also during the collection analyzed. And if anything is in violation or if anything fails, the end user can be alerted either in-app, they can be alerted via email, or we have an integration with ServiceNow where if anything fails, it'll just automatically create incident tickets for everything that failed in that collection.
Now, you mentioned federal STIGs just along the way. For those of us not in that parlance, security technical implementation guides, that
yes,
STIG?
That STIG.
Okay, so it sounds like some kind of compliance
Yes.
that they need to maintain. You can validate that that you are indeed in compliance.
Yep.
And so then not just STIGs, but I assume compliance for whatever else too, HIPAA, PCI, and so on. Could play in there?
You could definitely write those queries to do that.
Got it. Okay.
And is the idea here that I can sort of like write the query once and reuse it as needed and share them around and that kind of thing? Or is it sort of every time I do a task, I've got to come up with a new query?
Nope. So if you're looking at a specific thing, so if we go to that firewall management access list check, once that query is written, it's done. It's saved. It's saved into our, we have like a Git-like repo inside of the platform where all of the organizational queries are stored, as well as the queries that Forward gives you that you can play around with too, and you can change to do what you need to do.
Okay.
So once they're there, they're there. If you need to modify it, so say you wanted to extend that to Palo Alto, all you would have to do is take that same query and extend it to include how Palo Alto would look for that. The one cool thing, too, that we have is we know that this is by far one of the most popular features of the platform, to be able to query your multi-vendor, multi-cloud environment without knowing anything about anything that's out there, without knowing Amazon, without knowing Google, without knowing Palo, and get this information normalized and in an easily to digestible format. We also have a community where the basis of the community is for our customers to come and ask questions on NQE, like, hey, I'm having an issue writing an NQE query on whatever, or hey, I wrote this awesome NQE query and I want to share it with everybody here. Think of it like a Stack Overflow for Forward.
Right.
And if like you're actually having a problem with a query, we'll get like customers who'll jump in to answer it. We'll get actual guys who develop the product will come in and answer questions and help you and guide you along the way to get the query the way that you want it.
We've talked about things like, using this for firewall rule reconciliation and doing security checks and compliance checks. So I'm guessing that it's not just network engineers who may be getting into this console.
No. So we have three. So we have three main pillars of organizational people that can get into it, but it's not just those people, right? It's not just those guys. So we have SecOps guys who are coming in who can do things with incident response and CVE management. We have cloud guys who can come in and actually do things in the cloud, like I was explaining before, where, hey, if you're an Amazon guy and you're trying to work with an Azure guy and trying to paint that picture between AWS and Azure, network guys can come in. The platform can also have application guys self-feed themselves. So, Ethan, how many times in your networking days did you have an app guy come in and ask you, hey, I want to put something new in the environment. Can you tell me how many firewalls are in the path, or is there even a path between here and there?
No. It was more like,
never.
I have this servers going up today. Could you make sure everything's set to go? What?
Yes.
Come on, give me some notice, please.
So we can give those app developers access to the platform as well, and they can run their own searches to see this, so they don't have to bother the network guys anymore. So we're teaching them how to fish. So the network guys can do what the network guys can do and drink coffee and build networks.
In that order.
Yeah. And share memes.
Yeah.
Share memes. Yes.
Exactly.
It's important. Very important.
Mike, how do I fit forward into my network operations workflow? I'm thinking of things, practical things, the day-to-day kind of stuff like change control fulfillment. If I'm working through a change control, how does Forward help me get that change control done?
So we're going to approach it, since we've already talked about the automated way to do this, we're going to talk about the non-automated way to do this. So if you're not an organization that has adopted an automation framework yet. So
by automate, you're recalling potential snapshot, make change, snapshot, look at diffs, that process. Okay, but if I don't have that, I'm not a big automation shop yet.
Exactly. So we can still help you there too. It's just a more manual way of how I explain the iTential workflow. So you would come in, and instead of logging into all the devices and gathering all the show commands, gathering all the state you wanted to see, you would just go in and you would take a snapshot, and then you'd make the change, and then you take another snapshot. And then if you have verifications set up on that last snapshot, when you do a diff between the two, the pre and post, right, we'll show you everything that's changed. And then the same thing, if a verification went from passed to failed, now you have that contextual information during the change window. But, the bigger thing to that is if you have an organizational wide verification checks, and let's say in this change you modify a BGP prefix list, right? So you snapshot, you modify the BGP prefix list on whatever router you're going to do, and then you snapshot again. It may look good to you in the path that you're looking at, but your data center in Johannesburg could now be upside down because that prefix list propagated something that shouldn't have been in Johannesburg, and now it's offline. With the verification checks, if you have a verification check to look at something like that, that verification check will like go from passed to failed, and then you can see what either changed in config or what changed in state in order to make that data center go upside down.
Here's what's really intriguing about that to me. I've built a bunch of change controls like this. They were complicated. They were significant. They had, I had one change where I was going to spend the night bringing up BGP in an environment that didn't have it before and pull back a lot of the static routing that they had employed. There were several hundred sites involved. Lots of room for error, especially at 2 a.m. when you can't see straight.
Yep.
You come up with a set of checks to help sanity check that your change went well. You're manually going to run this, show me IPOSPF, IPBGP, whatever it is. And these are the things I expect to see. And, but you never think of everything. You never, and honestly, you don't really come close to thinking of everything. You come up with half a dozen or maybe 10 checks that are pretty solid and kind of important, top of mind things that you know how they should look. So a red flag goes up if something bad goes wrong. But you don't really know until 24 or 48 hours later that everything's cool.
Yeah.
This process, the way what you're describing means you don't have to think quite like that. Yeah, you got to think like that, but you don't have to be concerned about missing the thing you changed inadvertently because it just didn't occur to you. It's going to tell you.
Yeah. So I could like recall I was making a change. We had a routing loop between a Microsoft POP that we had in one of the previous organizations I worked in. The change documentation I had to submit to the change board was a 27-page Word document outlining everything I was going to do, from config to verification to rollback to this to that, right? And it was checked by me and my peers. So other eyes looked at this thing, and inadvertently, when ops made the change, they missed something. Yep. And it completely brought down Microsoft services for this particular organization. Now, if we take that same concept and put it into Forward, now all organizations kind of have a rough idea. I'm not going to say they're 100% accurate in this, but they kind of have a rough idea of what is important to the organization, what paths should always be working, no matter what happens in a change window. So if you have those predefined and you make a change, and then that change breaks one of those paths that wasn't in the purview of the change you were doing, you'd know that in the change window. So you can very quickly either know what happened and fix it, or roll back and figure out why you adding an extra AS number to this AS path prepend caused Johannesburg to flip upside down.
So I just want to make sure I understand what's happening. I use forward to take a snapshot of my network, but then I make the change in the production network itself.
Correct.
And then I take a second snapshot with forward, and then that's where I'm looking for where issues might emerge.
Yep. So now
I'm not testing the change first in forward to look at potential consequences. No.
No. All this happens in that change window. So, and it all theoretically could be done if you go in with a hours change window. It all theoretically could be done in that window, depending on how complex the problem is.
Okay. Yeah, I just wanted to make sure I understood that.
It's funny you bring up the time component of that, Mike, because that's the other big challenge, especially with a complex change.
Oh, yeah.
A big part of what you're trying to get done in that change window is your manual verification if you don't have a tool to help you.
Yep.
And then if things aren't going well, you still need to do your rollback, in that window as well.
And verify that rollback too. Yeah.
Yes, also. I've had that question come from my boss. Should we roll back? It's like, it's actually going to be harder to roll back and figure that out.
Yep. We just need to
We're just going to keep going.
Yes.
We're just going to keep going. All right, Mike. So we've talked about a change control example, how that fits in. We've talked about forward as a part of a network automation pipeline, some ideas there. Mike, we've almost been talking for an hour already. We're getting into 50 minutes at this point, and there's a bunch of cool things. So I guess we'll have to rapid fire talk about. One of them was inventory reconciliation.
Yes.
I think you mentioned kind of at the top of the show, but this was kind of a cool feature.
Yep. People will come out and say that and this is a direct quote from one of our customers. If they say they're a source of truth, it could be a source of lies. So your CMDB is only as good as the data you're putting into your CMDB. And network guys are really bad at updating things. Just look at Visio diagrams, and that's all I need to end with, right? They're not going to put in a ticket to put in a new device into a CMDB if they're not going to go and upgrade, and if they're not going to go and change that Visio diagram. It just doesn't happen. So,
which in fairness is usually a time thing, but yes,
of course,
right, it tends to not happen.
Tends to not happen. So as we were discussing in the platform, if you upload a seed list of devices and we learn about other devices, you can see it in a path search. So if you're doing a path search from A to B and there's a switch we didn't collect from that you didn't have, we'll say, oh, hey, this device is missing from collection. Do you want to add it? We have a NQE query that you can run that at every collection, say someone decides to plug in a new device and not tell anybody. It'll say, oh, hey, we found this new device. Do you want to add it to collection? So now when you take all this, Forward Enterprise turns into the network device source of truth, right? That we can then feed into ServiceNow. So now ServiceNow is the network device source of truth. We can feed it into Netbox, where now Netbox is now the true network device source of truth.
Because Forward, because of this device discovery capabilities you've got, are going to tell you every single thing, including that you still cracking me up. You said 2621 XM.
That's it.
How many of those could still be alive in production at this point, Mike? Come on, it's been 20 years, 25 years, maybe. Oh,
you never know, man.
So inventory reconciliation, very cool. You've mentioned the permit IP any mode, where you can say, would these two endpoints be connected if we didn't have access lists in the way, basically.
Yeah.
Prove that out. You've talked about path tracing in quite a number of times that came up, including ECMP, right?
Yeah. Yep, we'll show
Yeah.
you every path. So if it's, it could be one of one or one of 50, and you can just tab through each path.
Okay. Now, one thing we haven't gotten into too much is the security capabilities here, because you've mentioned Rapid7 and Tenable
Mhm.
integration. Can you just expand on that a bit?
Sure. So the security capabilities, the Rapid7 and Tenable piece is one piece of our overall security offering. So that is just an integration with one of those two platforms that we take data in, and we can actually take the data from the devices we know that are in the model and show you things about that, like vulnerability on it, if this host was compromised, you can actually run what we call blast radius and see what this host can hit.
Wait. So, okay. So a host, we're not saying it's compromised, but we're just saying, oh, it's got a vulnerability. If that vulnerability was exploited, what other endpoints on my network could this device possibly reach? And that's the blast radius?
Yep. Yep. So we can show you that. And it doesn't have to come from Rapid7 or Tenable, right? You can go, hey, I have this IP address. I want to see what this thing can hit because we suspect it to be infected.
Mm-hmm.
And then you can type it into our blast radius tool and it'll tell you everything both on-prem and in the cloud that host can hit.
Wow.
And then you can dig in even further, and there's a magnifying glass that you can click on that will actually show you a path search. So you can see, does the path even look correct? Like, is it supposed to be going through a security checkpoint? And if it's not, then you have more tools to go in and remediate that specific flow. And then the other thing we do, and this will resonate very well with a lot of network guys, is we do CVE management. So how many times have your security guys run a vulnerability scan at 2:00 in the morning and you get paged because your core router's tipped over because they ran a vulnerability scan on that specific platform that day? You get up, you look, it's like, oh, the security guys, nothing bad, hang up. Now you were, woke up. And so now you were awoken at, 2:00 in the morning. You get to work, you're upset because you were up early. And then sitting on your desk is a nice, lovely 1,000-page document of, oh, hey, this is what we think you have. Now you have 2 weeks to figure it all out and remediate it. It's like, oh, gee, thanks. How do you, like, this is just light reading on a, Tuesday afternoon, right? What we can do, so we download CV information from NIST and vendors nightly.
Uh-huh.
Because we have all your state information, we know the versions of code you're running. We know what you have configured. We can show you that you are vulnerable to this specific CVE because we matched your version number to it.
Uh-huh.
Or you are vulnerable to this CVE because we matched this configuration line to the CVE. So
that's really useful because sometimes these vulnerabilities depend on specific configurations, not just, the device instance.
So let's go in the Wayback Machine. Couple of months ago when Cisco came out with that CVS S10 HTTP one on iOS XE.
Mm-hmm.
Within 8 hours, our engineers had an NQE query written on the community that our customers could use to run to make sure that they weren't affected by it before it went into our vulnerability tool.
Well, Mike, as we close, there's one point of clarification I want to ask here. It's like I know you guys are multi-vendor, but we've used kind of a lot of Cisco examples in this. How multi-vendor is Forward Networks as a platform?
So we support a breadth of the world's network devices. So we support 33 of them currently today, from Palo to Versa to Arista to Forward to Juniper to 128 Technologies, just to name a few.
Okay, so I heard you just say like Versa and 128T, which was acquired by Juniper a while back, that those are like SD-WAN providers. So, I mean, it's as you put it early on, anything that pushes packets, you guys have deep knowledge of.
Yep.
Okay. I'm going to assume F5 networks.
Yeah, F5 too, F5 A10 if you want to go to load balancing.
Yeah. Okay. And then one other question is about licensing, Mike. We talked about a bunch of different features. Are there like 12 different tiers of licenses that I got to fight through to figure out how to get Forward to do the things I want to do?
So we don't require a degree in license understanding.
Okay.
Our licenses are really, really simple. It's per device that goes into the model. If you want to model what's in the cloud, we do something similar to how the cloud providers charge you on a per hour basis for cloud resources. So those are the only two. It's cloud compute hours for the cloud or a per device license for devices that go into the model.
Feature wise, I get everything no matter what.
Yep. Yep. One SKU, no seat license.
Got it. Got it. Okay. That's thankfully clear. I appreciate that, guys at Forward Networks. Much appreciated. Mike, how do I test drive Forward Networks, find out more information?
So if you want to see the platform, you can head over to our YouTube, and there's a bunch of videos that we've done that where like you can get a feel for the product. If you head over to forwardnetworks.com/packet pushers, we're actually going to have a list of places where we're going to be where you can get hands-on with the product.
And there'll be some other resources that Forward Networks is going to offer at forwardnetworks.com/packet pushers as well. All those resources will be ungated, meaning you don't have to exchange your contact information to take advantage of whatever it is that they're going to be sharing there. That's a turnoff. We know you don't want to have to punch in your name and your email and then have a salesperson contact you in 5 minutes. You can just go, and it's just going to be a nice page where you can get a better sense of what Forward Networks can do for you if you're more interested in investigating that platform. And of course, in the show notes, we will have lots of other resources for you as well. Mike, go back to you for one more question. If people want to reach out to you directly, are you accessible, LinkedIn or some other way?
I'm accessible more than I want to be accessible. So you can reach out to me on LinkedIn, Mike Lossmann, 2 S's, 2 N's on LinkedIn. On X, Mastodon, Blue Sky, I am at Packet Defender. Also, if you wanted to meet me in person to get a demo from me or from any one of our other technical guys, we're actually going to be at Gartner Symposium in October, AutoCon 2 in Denver, and Gartner IOCS in December.
AutoCon 2 in November. Excellent. The Packet Pushers will be there too. We're going to be covering the event. So, Mike, I guess you and me and Drew get to meet in person. That'll be cool.
That'd be awesome.
All right. Well, thank you to Forward Networks for sponsoring today's Heavy Networking. If you do your homework and decide to ping them, would you please tell them that you heard about them on Packet Pushers? We would really appreciate it. It helps us keep the lights on here when the sponsors that work with us know that you're listening. Now, if Heavy Networking, that's this show, if Heavy Networking is the only podcast you're listening to from the Packet Pushers, we've got a lot more. If today's topic on digital twins was interesting, you should also check out a couple of other podcasts, Network Automation Nerds and Total Network Operations. Those shows are right where you're living, at the CLI and the Git repos, and starting out and staring at the network observability dashboards. Aside from podcasts, visit packetpushers.net to find out human infrastructure and packet capture newsletters, our blog, community Slack, and YouTube channel, which reminds me, you can listen to all of our podcasts on YouTube if you want. We've been publishing there as audiograms for several months now, so enjoy that. Again, I've been Ethan Banks along with Drew Conway Murray, and we'll be back next week. Last but not least, remember that too much networking would never be enough.